In April of 2019, something unusual and deeply intriguing reached Earth from the depths of space. At the Parkes Radio Telescope in Australia, a massive dish that has been listening to the cosmos for decades, astronomers detected a signal that stood out from the usual background chatter of the universe. It was a narrowband radio signal, steady, focused, and drifting in frequency in a way that suggested movement. Unlike the messy static of natural cosmic phenomena, this signal appeared structured, more like something engineered than accidental. And its apparent point of origin? The direction of Proxima Centauri, the nearest star system to our own. For a brief, electrifying moment, astronomers wondered, had humanity just caught the first evidence of intelligent life beyond Earth? BLC-1. A signal from our neighbor. The signal was quickly catalogued and given a name. BLC-1, short for Breakthrough Listen Candidate 1. It caught immediate attention not only because of its unusual properties but because of where it seemed to come from. Proxima Centauri lies just over 4 light-years away, cosmically close. Even more tantalizing, it is home to Proxima b, an Earth-sized planet orbiting in the habitable zone, where temperatures could, in theory, allow liquid water to exist. Suddenly, the dream of detecting another civilization didn't feel so far away. Instead of being hidden in some distant galaxy, the answer to, "Are we alone?" might have been whispering to us from the star next door. Echoes of the "wow" signal. The discovery instantly drew comparisons to another legendary mystery, the "wow" signal of 1977. That earlier detection was a 72-second burst of radio energy picked up by the Big Ear Radio Telescope in Ohio. It was so distinct that astronomer Jerry Emmon famously circled it on the data printout and wrote, "wow," in the margin. To this day, no natural explanation has ever fully accounted for it. But the "wow" signal was fleeting, gone almost as soon as it appeared, never to be repeated. BLC-1, by contrast, was different. It lasted for nearly 2 hours. It was more precisely measured, better documented, and, most intriguingly, it appeared to line up with the nearest potentially habitable star system. That made it, for a while, even more compelling than, "wow, could this be the one, the first true techno-signature from another intelligence?" Digging into the data, excitement spread quickly across the scientific community. NASA scientists and researchers from the Breakthrough Listen project, the world's largest coordinated search for extraterrestrial intelligence, began combing through the raw data. Using advanced software pipelines like TurboSETI, they reprocessed more than 30 hours of telescope time. The result was fascinating. BLC-1 appeared consistently when the telescope was pointed toward Proxima Centauri. And yet, when the telescope turned to off-target locations, the signal disappeared. This suggested the source was truly celestial, tied to the star, not to Earth. At first glance, it looked like the strongest candidate for alien technology ever found. But then, deeper analysis revealed a twist. When scientists expanded their search across other regions of the sky, faint signals began showing up, signals that looked suspiciously similar to BLC-1. And these appeared where no star or planet should have been transmitting. That raised a new, uncomfortable possibility. Perhaps the signal wasn't extraterrestrial after all. The interference puzzle. What followed was months of painstaking investigation. Radio telescopes are incredibly sensitive instruments, capable of detecting faint whispers from billions of light-years away. But they are also vulnerable to contamination from closer sources, aircraft, satellites, even electronics on the ground. Eventually, the team homed in on the likely culprit: radio frequency interference generated by Earth's own machines. The most convincing explanation came from within the telescope itself. Oscillators, electronic clocks, inside the Parkes hardware, can sometimes leak signals, mixing and producing frequencies that mimic real astronomical phenomena. Once this was modeled, the mystery unraveled. The strange frequency drift, the persistence, even the apparent link to Proxima, all of it could be recreated using mundane interference. BLC-1 wasn't a message from the stars. It was an echo of our own technology, masquerading as something alien. Lessons from a false alarm. By 2021, the verdict was in. BLC-1 was not an alien beacon. Two independent studies confirmed what the data had been whispering all along. The signal was the result of Earth's own electronics, masquerading as something extraordinary. For many, the news landed with a heavy sigh. The dream of hearing from Proxima Centauri, from neighbors just 4 light-years away, evaporated. It felt like a door had closed. But in science, disappointment often conceals progress. And in the case of BLC-1, the false alarm became a milestone in disguise. The episode forced researchers in SETI, the search for extraterrestrial intelligence, to sharpen their tools. It showed how easily human technology could imitate alien technosignatures, and how vigilance was essential. Teams expanded their databases of interference, cataloging the fingerprints of everything from satellite transmissions to faulty electronics. Algorithms grew more sophisticated, trained to spot subtle patterns that distinguished genuine signals from human noise. Most importantly, the episode reinforced a rule as old as science itself: extraordinary claims demand extraordinary evidence. A real extraterrestrial signal must be repeatable, must be verified by independent instruments, and must pass every test of skepticism before being embraced as truth. BLC-1 was not the alien message humanity hoped for, but it made sure that when the real one arrives, we will recognize it without hesitation. Why BLC-1 still matters even as its extraterrestrial origin was ruled out. BLC-1's cultural and scientific impact rippled outward. For a brief window, humanity was united by wonder. Astronomers debated, engineers recalibrated, philosophers pondered, and the public imagined what it might mean if we were not alone. A signal from Proxima Centauri, our closest star system, would have transformed our view of the cosmos overnight. And though it proved false, the experience reminded us of something essential. SETI is not just about finding aliens. It is about refining our methods, challenging our assumptions, and acknowledging the limits of both our instruments and our imagination. In that sense, BLC-1 achieved something profound. It showed us the razor's edge on which science balances, between hope and skepticism, between imagination and evidence. Proxima and beyond. The interest in Proxima Centauri did not fade with BLC-1's demystification. Quite the opposite, it intensified. Proxima remains one of the most tantalizing stars in the sky. Its planet, Proxima b, lies in the star's habitable zone, raising the possibility, however slim, of oceans, atmospheres, and perhaps even life. At the same time, Proxima's violent stellar flares pose a challenge, bombarding the planet with radiation and raising doubts about habitability. This paradox makes Proxima b a perfect laboratory for the future of exoplanet science. Projects like Breakthrough Listen continue to monitor it for radio emissions. Meanwhile, the James Webb Space Telescope and next-generation observatories aim to probe its atmosphere for chemical traces of life. Future missions, armed with powerful coronagraphs or even space-based star shades, may allow us to directly image the planet's surface. And then there is the boldest vision of all: laser-propelled probes. Concepts like Breakthrough Starshot imagine fleets of tiny spacecraft, accelerated by ground-based lasers, traveling at a fraction of light speed. Within a human lifetime, they could fly past Proxima b, sending back images and data, not a signal, but a first-hand encounter. BLC the 1st of May have faded, but the quest it sparked is alive and growing. The bigger picture in the end, BLC-1 was not the alien call we longed for. But it did something remarkable: it prepared us. It taught us to be cautious in the face of wonder. It tested our instruments and revealed their flaws. It reminded us that the first voice we must untangle in the search for life is our own. And it reignited the most enduring question humanity has ever asked: are we alone? The universe did not speak in 2019. But in its silence, it gave us something else, a rehearsal. The next time a narrowband signal cuts through the cosmic noise, we will be ready to test it, verify it, and understand it with sharper precision than ever before. And if that signal truly comes from beyond Earth, whether from Proxima or some distant star yet unseen, it will not be dismissed as interference. It will be recognized for what it is: the moment humanity first heard another voice in the universe. Until then, the lesson of BLC-1 is clear. We must keep building, keep refining, and above all,